Hello, my name is Peter Walsh. I'm an air quality scientist at WSP, an engineering and environmental consultancy company. I'm here today to talk to you about the Greater London School and Nursery air quality audits and monitoring conducted by WSP. So an overview of my presentation today. I'm going to just do a quick introduction to the policy context around the work that we conducted. Also step you through the school and nursery air quality audit program and what that process involved and what the outcome of those audits were. And to talk to you about the baseline air quality monitoring that was conducted across 20 nurseries, and then I'm going to lead you into the more detailed air quality survey which was conducted in a subgroup of 6 of those nurseries within London. So firstly, the policy context around the air quality audits and the monitoring. So the Mayor of London has prioritised air quality in London as one of his key issues. He feels that children's exposure to air pollution is one of his key policy focuses, and that one of the tools that he's commissioned have been air quality audits. And this air quality audit program has commissioned to identify a number of hard-hitting measures and combine those with some quick win solutions. So effectively, the Mayor of London feels that London's dirty air is a public health crisis. So from the air quality audit and monitoring program, the project objectives that we set out was that air quality audits were to be undertaken at 50 schools in London and also undertaken at 20 nurseries. So these are audited for both indoor and ambient air quality. WSP developed and established the audit methodology, and then from those audits there was a series of recommendations that we were looking to develop, which should be easily executable, and they were aimed at reducing pollution exposure. The baseline indoor and ambient air quality monitoring was to be completed in 20 nurseries, and then we were going to move that on to a detailed air quality survey of 6 of these 20 nurseries. So the air quality audits, what's involved? Well, in September 2017 to January 2018, 50 schools were audited in London, primarily in the centre but also on the outskirts, and then between May 2018 to September 2019, 20 nursery schools were audited, and those were audited primarily in London, in and around the ultra low emission zone and the low emission zones for London. So those were the target areas that we felt needed to be looked at in terms of potential high exposure of small children to poor air quality. So in terms of the contributions, in terms of the audits themselves, stage 1 of that audit was preparing a desktop research and identifying outdoor sources of pollution and exposure hotspots. So we did this by assessing the contribution to emissions made by each vehicle type. So we used information that was available through the Greater London Authority to do that. From that we looked at the road transport emissions, when they're split by source sector from motorcycles through to taxis, LGVs, HGVs through to electric cars, and then also by the transport, road transport and volume of vehicles, and the emissions attributed to each of those volumes. We also downloaded some air quality modelling undertaken by the GLA for each area around each school, and that was primarily for nitrogen dioxide and PM10. So that's a map of the nitrogen dioxide concentrations from blue through to red and purple from high concentrations. And you can see in the middle of the road of road junctions, you have much higher concentrations of nitrogen dioxide and this is a dispersion model which has been used by the Greater London Authority and the Transport for London Agency, and it's publicly available information for this audit. As part of stage 1, we were preparing desktop research, so we needed to understand the local context. And for that, we undertook a travel survey to each nursery school, so we understood what the breakdown of travel was by the staff, and then their means of travel to nursery school. So what's the method by which staff chose to travel to their nursery, and then also the transport routes in and around that school and that nursery. So what were the options for staff to travel and pupils to travel to that nursery school, and then also what were the links around the nursery school in terms of transport links, public transport, and also car parking. And that gave a snapshot really of what the options were in terms of discouraging staff members from using private vehicles and switching from private vehicle use over to either active travel or public transport where vehicle emissions were lower, therefore improving air quality locally. There's also a certain amount of field work which drew all that information together. So we had a schedule for an audit schedule, and that field work involved site walks around the school and the nearby roads, undertaking a brief transport assessment and audit of peak arrival times and departure times for parents dropping off children. And these audits are undertaken with borough school staff, including air quality officers and school transport staff. There was also an audit of the inside of the school, the internal area of the school, so an internal site walk, and that allowed us to appreciate the layout of the buildings and also any emissions that might be occurring from the school itself, such as boilers and so forth. So we conducted a school building audit as well as part of this. All of the methodology for conducting the site visits and also the desktop studies were compiled into a systematic methodology. So we had a universal approach to undertaking these surveys, these audits. So different members of staff were able to undertake them without varying the methodology or introducing a bias to those. So in terms of mapping, stage 3, we were looking at a high-level assessment of air quality data. We used a local London atmospheric emissions inventory data, which is publicly available and produced by the Greater London Authority for public consumption. And from that, we mapped the school location. We used school Department for Environment mapping. And we looked at nitrogen dioxide in an area of 150 metres around each of those schools. We looked at the annual mean nitrogen dioxide for each school, and we also looked at the vehicle numbers around each of those schools, as well as the road nitrogen oxide emissions. That was drawn around a 200-metre buffer around each centroid. So, for example, this is some air quality mapping that was conducted for one of the primary schools, Hasseltine Primary School in Southwark. So we have our location of the school there. We have the mapping data, which we downloaded from the London Atmospheric Emissions Inventory. We put a 150-metre buffer around that, and we extracted that to understand what the potential risk and exposure of children to nitrogen dioxide in that immediate area to the school was. We also looked at extracting out the road link data, so what the traffic data was in and around that school area, as well as nearby emission sources, so industrial sources that may be significant sources of pollutants to air. So what did we find from the school audits? Well, the results were that there were some key reoccurring issues. Primarily, we found that in terms of roads and highways, that the roads closer to school were very heavily trafficked. This is London, after all, and there's a high level of congestion. And in London, road transport is responsible for 50% of nitrogen oxide emissions. And of that 50%, 32% is from buses, and quite a large number of buses actually pass the school. And 22% of that 50% is actually emitted by lorries and freight activity, which also pass the school. There was a high level of congestion and queuing in all of the schools and nurseries that we audited, often around drop-off and pick-up time where traffic was queuing back from junctions. There was also use of small routes by commuters driving very fast along these routes in order to get from main arterial highways, and that's called rat running, and that occurred quite frequently past these schools. So generally the environment around the schools and nurseries were considered to be hostile environments for pedestrians and cyclists as well as scooters. There was a lot of engine idling observed of people pulling over, maybe getting out of their cars or leaving their cars running while they allowed children and others to be dropped off at the schools. There was a high level of construction activity close to the schools and nurseries, and we found that some of the schools had major facilities that attracted major trips, either public facilities or attractions or places of work, though there were rail and tube lines close to most of the school sites. So as an outcome of those audits, there was a toolkit of measures developed, and these were developed in order to improve air quality in and around the schools and nurseries. The toolkit is comprehensive and comprised of over 100 measures, and these measures were assessed against the key criteria, including their potential air quality improvement, the wider benefits of the measures, such as climate change and greenhouse gas reductions, the cost of those measures, how deliverable they were, and also what stakeholder support. Was the school keen on these? Did we think they'll actually pick up on them and work with them? The measures were also a combination of hard-hitting measures as well as low-cost approaches, which would be picked up easily. And we also included some precedents here, what we felt we were doing as a first thing, was innovative, and also some examples of some of those measures. And there was a publication in May 2018 of a summary of those toolkits of measures to improve air quality in schools, as you can see here. And on the right, there's a typical example of some of those measures, including highways measures and school site measures. So those that can be taken up by a school site itself, but as well as some behavioural measures and wider measures that can be picked up by government and other agencies. So on to the air quality monitoring of schools and nurseries. So the schools audits didn't involve any monitoring, but the nurseries audits did, and from those we had 20 nurseries to conduct monitoring in. We looked at nitrogen dioxide concentrations, and we did that using passive diffusion tubes here on the left. We looked at volatile organic compounds, and we used sorption tubes. The centre picture there is a typical sorption tube, and also we looked for formaldehyde inside the buildings, inside the nurseries, and for that we used passive sorption badges to look at formaldehyde. So the indoor air quality of the nurseries was undertaken using 5 nitrogen dioxide diffusion tubes. Only 1 formaldehyde diffusion tube was deployed, as it was a pollutant that's only known to be generally inside, and we only deployed 1 VAC tube because the costs of those were prohibitively high, so we felt it was useful just to have 1 inside the buildings. The nitrogen dioxide diffusion tube samples were placed at the roadside outside each of the nurseries. There was also one placed immediately outside the nursery entrance, so outside of the building, but not at the roadside. One was also placed in the playground, in the middle of the playground, away from the roadside. One was placed immediately inside the nursery entrance, and then we found the final one was inside a nursery classroom. Both the formaldehyde and VOC samples were also placed within a nursery classroom. We mapped each of the concentrations we found for the 20 nurseries against the London atmospheric emissions inventory modelled air quality concentrations for comparison. So the nitrogen dioxide concentrations we found at the 20 nurseries were generally for roadside very high. For the playground sites, not quite as high. The nursery entrances, we actually found that a lot of the concentrations were high, probably because the playground sites were further away from the roadside than nursery entrances. Inside the nurseries, we found that the concentrations for nitrogen dioxide from diffusion tube samples dropped, and inside the classrooms they also dropped. The VOC concentrations were relatively low inside the classrooms, though there was some occasional peaks in concentrations, though these are all below guideline values. And the formaldehyde concentrations were also low in all of the samples in all of the classrooms. So if we compare the nitrogen dioxide concentrations against those modelled using the London atmospheric emissions inventory, we find that they're comparable, that there's a good correlation between the London atmospheric environmental emissions inventory concentrations at roadside close to nurseries and the roadside concentrations as monitored during our surveys, which is reassuring. But we can also see that the modelled air quality concentrations predicted that there would be high concentrations of PM2.5 at those roadsides. We didn't monitor for PM2.5 in the 20 nurseries. So just to summarise, the further from roadside that the nitrogen dioxide samples were placed, the lower the concentrations. So as we moved away from roadside to playground, nursery entrance and inside to the nursery and classrooms, then the concentrations of nitrogen dioxide decreased. We found that there were consistently lower levels of nitrogen dioxide indoors than outdoors. There were some instances of high VOCs, but they were both typically well within guideline values. And the PM10 concentrations were fairly high, and there was a good agreement between the model concentrations of nitrogen dioxide and the monitor concentrations. So how did we select our 6 nurseries for the detailed air quality surveys? They were used, we've put all that monitoring data as well as the audit data into a spreadsheet, and we conducted a weighted calculation, and from that we found there were 6 preferable nurseries, and these were those nurseries: Columbia Market, Rachel Macmillan, Nell Gwyn, Pembury House, Thomas Coram and Dorothy Gardner. And this is a weighted calculation as an outcome from both the audit and also the air quality data. All of these nurseries have got very high concentrations of nitrogen dioxide at roadside. As you can see, this is the results of their baseline concentration data for nitrogen dioxide. And also they're predicted to have high nitrogen dioxide concentrations by the London atmospheric emissions inventory as well as PM2.5. So those were our 6 nurseries that went on, candidate nurseries that went on to have detailed air quality surveys. So in order to conduct the detailed air quality surveys, we used the 2 methods. We redeployed our diffusion tubes for nitrogen dioxide, and also we introduced a new monitor, a PM2.5 and a nitrogen dioxide monitor called a Zephyr, which is a continuous monitoring device, an indicative monitoring device. The key criteria to this monitoring device was it was low noise, and so it did not disturb classroom activity. So moving on to the results. Well, this is the first nursery we monitored, now Gwyn Nursery, and these are two charts at the top here. One is for nitrogen dioxide averaging for the midweek, weekday concentrations and a weekend concentrations over a 2-week period. These are only deployed for 2 weeks. And on the right there, that's the PM2.5 concentrations. Again, in blue, weekday concentrations, and in green, the weekend concentrations. And at the bottom there, that's a summary of the nitrogen dioxide monitoring that actually took place during the baseline, because we monitored inside and outside that particular period. So you can see there's a high variation between weekday and weekend concentrations for these averaged over 2 weeks. So there's generally peaks that we can see. There's a peak here for the mid-morning, probably there's a drop-off of pupils, and there's a peak in the PM2.5 for late afternoon, probably from a pick-up. But generally, there's a strong diurnal pattern between those. And we can see that the roadside concentrations for that particular nursery are very high for nitrogen dioxide, and they begin to drop away until you go into the classroom, where it reduces significantly. At the bottom there, there's a ratio of the indoor to outdoor difference in concentration, and so you can see by the mere fact of moving from the outside to the inside, you actually reduce concentration significantly. So the indoor concentration is actually 72% of what it is outside from January, and in February it's even lower. So there's a strong attenuation impact of moving from outside to inside at Nell Gwyn Nursery. Those patterns are repeated. This is a slightly inconsistent sample, as the February diffusion tube samples were compromised, but in terms of the Zephyr, the continuous analyzer results, you can see there again strong signals there, a strong peak during the weekday, mid-morning, and Columbia Market, and again less strong, but still a peak in late afternoons, again associated more than likely with the drop-off of pupils and the pick-up of pupils. The PM2.5 had a strong signal in the early to mid-morning, which is also repeated during the weekend. This is unusual because this Columbia Market actually has a very, very famous flower market during the weekend. So those concentrations are probably associated with movements in and around the market, not to do with the school activities itself. Again, you can see some very strong reductions of nitrogen dioxide concentrations by moving from outside to inside the classroom. So the ratios are fairly low in terms of the outside to inside concentrations. Third nursery, range from minimum. Once again, we have a strong diurnal variation there, much lower concentrations of PM10, and again a very strong indoor to outdoor effect by moving from the outside to inside. You reduce your potential exposure of nitrogen dioxide. That's repeated again for Pembury House and for Thomas Coram, and also for Dorothy Gardner. Unusually, there's actually a reverse peak here. So we've got, for some reason, we have an increase in nitrogen dioxide concentrations either end of the day for Dorothy Gardner. But once again, you can see that there's a strong attenuation from moving from outside to inside for nitrogen dioxide, and there's some very strong peaks there for PM2.5 during the weekday samples over the weekend samples. So just to summarise, these are the results of the continuous monitoring results from the classrooms, and these are the nurseries here on the left. The concentrations are for nitrogen dioxide and for PM2.5. The nitrogen dioxide concentrations for weekday samples for all the nurseries were very slightly higher than the weekend, with exception to Dorothy Gardner. There was an anonymous result there. And the average difference between the weekday concentration over the weekend concentration was 2.24 micrograms for these 6 nurseries. And in terms of PM2.5, the concentrations were very low. They're all below 6 micrograms a cubic meter. And the concentrations for the weekday samples were generally all much or slightly higher, about 10% higher than the weekend concentrations. And the average difference between each of those was 0.47. So again, about approximately 10% difference between the two. So there seems to be a larger average difference between the weekday concentrations for nitrogen dioxide than the weekend concentrations. So just to summarise, in terms of the nursery school air quality findings, we found that nitrogen dioxide concentrations were higher at roadside than in nursery playgrounds, which is understandable. We found that there were clear and substantial reductions in nitrogen dioxide concentrations when you moved inside the nursery building itself. The use of the continuous analyzer, the Zephyr, reveals some substantial diurnal variations in nitrogen dioxide concentrations within nursery classrooms. And overall, the weekend trace nitrogen dioxide concentrations were typically lower when compared to the weekend traces, and this is reflected in the lower activity rates expected when the classrooms were not in use at the weekend. So thank you very much for your attention, and I'm happy to have any questions emailed through to me. Thank you.